Hello and welcome to the new session of file handling in C language. This is part 4 and here we will discuss about various methods to store the data to external files with the help of four basic functions: fprintf, fputs, fputc, fwrite and the sample code related to it. Finally, we will have two more points: end of the file identification criteria and use of ferror function. As my earlier lectures, here the resources are same. A book written by Yashwant Kanitkar, a book by E. Balagurusamy, a book by Ajay Mittal, and some resources from Wikipedia. So let's start with the first method, that is fprintf. Fprintf statement is used to write a formatted output on a stream. What stream means? Here our stream is file. The syntax for that writing purpose is integer fprintf, file pointer stream, character string in terms of format. The function writes to the specified stream. What stream is? This is my file where I want to write. The data that is formatted and specified by the format argument. So I can write some data to a file as per my formation. What it means, we will check it in the example. So here is a sample example. What is the step 1 of any file handling program? I have to create a file pointer fp. So I am creating over here. This is my step 1. Then I am utilizing or declaring some variables in terms of integer I and a string of size 20 whose name is name. Float salary, a variable to store some data on salary, and then I will check that whether this fp is workable with some file or not. So fp is equal to fopen abc.txt some file and see here what I have did. This is in write mode. This is write mode. In all previous cases, I used R in place of this W. So if it is openable, then okay. Otherwise, I have to check whether it is null. If it is null, then I have to take an exit from my program. So if fp is equal to null, print some statement that file is not found and finally take exit. But if file is writable, then I have to read some data for my name and salary and then put it to the abc.txt. So for I is equal to 0, let I is less than 10 means I want to read 10 such records and then finally put those 10 records to my file. Put as enter your name, get as name, this will hold the value given to name. Similarly, I will read a salary part, %f, ampersand salary, and see. After holding some data on my variables, I am using flush statement. Flush basically clears your buffer. So what is in buffer will be cleared, and next onward a fresh data entered by you from the keyboard will be the only input for a particular variable. And see here my formation take place. I have taken name and salary. These are two. But in terms of file, I am mentioning something else also. This is my formation. That means along with data, some statement will be there. Along with data related to salary, a salary statement will be there. And this I belongs to which number of record you want to submit, what is a name to it, and what is the salary of that particular name of employee. Once all such operations have been done successively, you have to close your for statement, and once all such entries have been done, then close the file and finally end up your program. Now let's move to the editor and then try to make this program on editor also. So we move to editor. So here is the editor. Here I will write a program. First, include the header files. stdio.h, then hash include stdlib.h because we will use exit, and then void main, this is end main. Now first try to make a file pointer, file asterisk fp, open a file to it, fp is equal to f open, say some file, say abc.txt, give its mode as w. Now check its status. If fp equals to null, then do two things: printf, printf file can't be open, terminate it, exit 1. If file is openable, then I have to write some data to it. So for writing, let us take salary as the content, float salary, some integer counter kind of thing. Now a name where I want to store a salary, 20, this is a name of a person, and we will allot a name as well as salary to it. Now for I equals to 0, I is less than, say, to keep it small, I am giving it 3 plus plus I. Now read some data, printf /n enter name. Get s name, then again printf enter salary, If it is not visible to you, I am going to enlarge it. Salary, scanf, %f, then M% salary. This has been done. Now I have to write this statement, these values along with the statements to the file. So how I will write it? fprintf in a new line, say name equals to %s, then some tab, then salary of person equals to %5.2f, just to format the decimal places. Now name and salary. This has been done. After it, this will read 3 such data. I close the program, fpf close, fp, and my program ends over here. Now compile it. Okay, what is it is saying? Oh, termination point at printf is missing. Okay, this has to be flushed also. F flush stdin. Okay, in fprintf, first statement should be the stream where I want to redirect it. So fp, then my formation of string, and then variable provided to it. Recompile it. It is error free. Run it. Say first one is J, having some salary. Second one is Ajay, having some different salary. Then Vijay, having some another salary. So it has been done. Now check whether this abc.text is created or not. ABC. Yeah. Name Jay, Ajay, Vijay, salary 10,000, 30,000, 50,000. If you recompile this program, then all earlier content will be removed. Let us rerun this program. Say Arun, some salary, Karun, some salary, and Ajay, some more salary. It is over. Let's check the file. Again ABC, C. New records are there. New records are there. Earlier are removed. So now move back to the slide. Next function is fputs. Fput is unformatted function. Here I will read some data from the keyboard and push it to my file without formatting it. So syntax of this fputs is this returns some integer value. If it is successful, then the value, otherwise error point. Fputs, this will read a stream, what content you want to write in terms of a string and where you want to write. This will show you content to be written and where I have to write. Fput writes the string pointed to by str to the stream pointed by the stream. On successful completion, it returns 0. In case of error, it returns end of file. Here is its example, a very small example. Let I have file pointer fp. Let I have file pointer fp. One string named by str and it can accommodate 100 odd characters. On fp, I open one file with the mode write and check whether it is openable or not. So if fp is equal to null, file cannot be opened, take a exit. But if it is openable, then what to do? Kindly give your some feedback kind of thing, and I will store this feedback to the string called str, and after reading it, I clear my buffer, and finally I put this value to my file with the help of fputs function. So fputs, this the earlier is what you have to write, and this fp defines where you have to write, what to write and where to write. And finally close your program with the help of close fp function, terminate your main. So this is a very simple example of fputs. Now move to the editor. So I am taking this particular part from the earlier program, create one more file, write the step 1 kind of data. Now declare one more variable to store some message. Say message of size 200 is there. Printf some statement and read its feedback with the help of getS function. GetS, where I have to keep it on MSG, message. This has been recorded. Now put this message to the file. What function I have to use? I have to use fputs. Fputs, what it takes? The first one, what you have to write means message, and then where you have to write means a file stream fp. Once this has been written, close your file, close close your main method. End main. Now we will try to compile it and check is there any error. Give some name to it and save this file. Let's check. No errors are there. No error, no warning. So we will move to run this program. Give your feedback. Yes, my feedback for the session is that and sometime I also have some queries queries. Let's see. No errors are there. What file we have taken? We have taken a file abc1.txt. Let's move to it and check. Is there? Yes, here is. It is created abc1.txt. Yes, this is what we took. So now you can see that what you have typed on the black terminal screen is already inside this abc1.txt. Now move back to the slide. Next is fputc. The fputc function is used to write a character to a string, not a whole string, but character by character. Its syntax is integer fputc, integer c, and file stream. What C? I am talking about writing character, but here it is integer, means I have to take ASCII value of the character. This is what I have to take. fputc function will write the byte specified by C to the output stream pointed by the stream, means whatever I take it from the user, it will be written in terms of bytes to the file. Upon successful completion, it will return value it has written, or in case of error, it will give you end of file. Its example: hash include stdio.h, a main, some file pointer. I have taken one integer variable I. There is a string to hold some data. Try to open one file in a write mode. Check whether file is openable or not. If it is not, take an exit. And if it is so, then I have to take some output from user to this, and finally that output has to be stored to file. Get as string, and I have to put this get as string to the file. But note down, in the earlier one I have used, see, let me check it. So see, let's take it the fputs function. What I did, I used fputs one time, no looping content is there. The whole string has been passed with single statement. But in case of character, what I have to do? I have to read one by one and transfer that one by one character byte to the file. So I will take a loop whose strength will be up to the size of my string, means strlen of str, and then I use character to be stored on the file fputc stri fp. So its ASCII value will be stored over there, and keep on doing until all the strlen characters are not been placed, and keep on doing until the whole str length is not being consumed. Finally, close your program, and before closing your program you have to close the file also. Let's move to the editor to have such program on that also. So I will rename this particular program and convert it to the fputc one. So this is my program, stdio.h hash include stdlib.h. Say here you have to use one more header file, include string string.h, because strlen is stored in that. File pointer has been declared. You have opened one file to it. Make it abc2.txt. Then check whether file is openable or not. If it is not, take an exit. Otherwise, you have some string called message. Give a instruction on a keyboard, on a terminal, give your feedback, read that message, and in spite of using this fputs, we will try to use a loop construct. Integer I equals to 0 for I equals to 0, I is less than strlen of my message, and then plus plus I. Inside this, use fputc function. What I have to write? I have to write first character of my message to the file pointer. This is the main point. So this one single statement has been converted into these two statements. Let us compile it. What happened to it? Yes, error free, warning free. Let's try to run it. Type welcome to the class showing an example for fputc function. Here we are trying to explore it. Thank you. Press enter. Your job is done, and let's see whether this welcome to class showing an example kind of message is there in abc1.text or not. Here it is. Yes. Welcome to the class showing an example for fputc function. See, whatever I have written over there, now in this inside abc2.text. This is how you can use fputc function. Now coming back to the slide for our last function, fwrite. So the next one is fwrite. The fputc function is used to write character to the stream. Fwrite works only with binary file. Yet this is a difference. fputc use character by character to stream. Fwrite works write character by character, but in terms of binary files. So for fwrite function, I have to open my file in WB mode. Its syntax is fwrite void pointer string size t size t count file pointer stream. Let me mark it what is it is trying to say in terms of some. This is your source. This is your target where you have to write. This is how much you have to write. And this shows I'm writing its content over here, and this shows what is the size of one time writing effort. Means chunk size, and this defines overall number of chunks. This is how you can understand this fwrite function. Let me clear the handwritten content. Fwrite will write to the stream from the array pointed by str up to the count object of size specified by the size. Means where you have to write, what you have to write, it is in terms of string. How much you have to write, it defines by term count, and one time writing effort is defined by size. So all four such arguments. The file position indicator of fstream will be advanced by number of bytes successfully written. Means if this is 4 byte and you have to write such 40 bytes, then 4 byte will be written once and it will jump to the next 4 bytes. That means file pointer will not move to the second byte, it will move to the 5th byte after successful written action. Let's have an example to it. Create a file pointer. Some variable is there in terms of count. I have taken some string and populated it with some message, say good morning, trying to use one file named mydoc.txt, and this is a main point. In which mode I am trying to use? FW. If you remember, when we used fread function, there we have used RB. That means binary read, and here we are using binary write mode, and check whether it is functional or not with the help of fp is equal to null. If it is not functional, take an exit. Otherwise, what you have to do, you have to write this string to your file. So this is your source, this is your target. How much you have to write at once? This means 1 byte, 1 chunk size, and overall number of chunks will defined with the help of that overall length of your string. So this count will say how many bytes have been written to file, and you can take a print for this also. Printf %d bytes were written to the file in terms of count. Finally, close your opened file with the help of fclose and close the function itself. Let's try to develop this program in editor also. So I use again a common content for my new file up to this point. Create a new one, new source file. Write the common content stdio.h, stdlib.h, string.h. I have created one file pointer. I am using a new file, say abc3.txt. Its mode will be wb. Check whether this file is openable or not with the help of null assessment. fp double equals to null. If it is can't openable, take an exit. Declare some string in terms of message, say its size is 200. Printf, give your feedback, and this feedback has been stored with the help of getS function. Now I will use a count, integer count is equal to fwrite. Now see, what was the first argument? What I have to write? I have to write message. What is the size of one write element? 1 byte, write once. How many bytes I have to overall write in? How many bytes overall I have to write? With the help of strlen. strlen, whose length? Message length. And finally, where I have to put my writing content? On file pointer. And this is what fclose fp, that means close your file and end your program, and min. So see, up to this particular point nothing has been changed. I have used one counter, and count will define how many bytes I have written. On the fwrite, count will decide how many bytes I have written to the file defined by fp. For a safer side, you can also take a print of it also. printf /n, you have written %d bytes to the file, count. Then finally terminate the statement. Let us compile it. It is asking some name. Give it p4f write write of category C. Save your program. And now we will compile it again and see what happens to it. Zero error, zero warning. Everything is okay. Now run the program. Feedback. This is the last program of the session. Check what has been stored to abc3.txt. This job is done. Come to the file folder. abc3 is created. Now check. This is the last program of the session. This is the last program of the session. Check what has been stored to abc3.txt. So whatever you have typed on the terminal is now stored in abc3.txt. Now come back to the slides. Now we will check what are the different ways to check whether file ending is there or not. To detecting end of file. There are two ways to detect end of file. The first one is while reading the file in the text mode, character by character, the programmer can compare the character that has been read with end of file. This is the symbolic constant defined in stdio.h with the value -1. It means if it is returning -1 means end of file has been reached. Second one is using fEOF function. Its syntax is this will give you some integer value. fEOF function to the file pointer. Returns 0 when it is false, means when file is having some content it will give you false, and when it has been reached the end point then it will return true, the end of file. Return 1 as true if the end of file has been reached. Here is a sample code related to it. The first one is having EOF and second one is having file end of file function. See, here it is true up to some extent. C equals to fgetc fp, and if C equals to end of file, take a break and print C to C. अगर ये नहीं हो रहा, if it is not end of file, then it will be directly written to C and next character will be taken up by the file. And in second case, this is always true. And see, if not file end of file means it is not 0. Fgetc, take a string, its size and store it to some file. And this is how you can equate these two as equivalent to each other. Either use end of file comparison or use file end of file function. Both are same. As per your need, you can use them. Error handling during file operations. You have one function called ferror. Its prototype is this will give you some integer value. Ferror in fstream means ferror inside fp. What it gives? Let us check. It returns 0 if no error encountered, a non-zero value if there is an error. Means if integer is non-zero, this means some error has been encountered. You can use this function in any of the earlier program. In case of error, the programmer can determine which error has occurred by using p-error. Type of error can be observed with the help of p-error function. This is a simple program of fwrite, and here a error has also been used. If writing so some error has been occurred, then how I will identify it? This is a new line. If ferror fp, printf error writing in file, and then take exit. So when you find error writing in file in the file named my.doctext, you can easily identify that there is an error while compiling this fwrite function in my program. Close the file, close the main, and this way you can add to check whether error is there or not. This is all from now, and in next session we will have few more important programs, directly programs written on the editor, which are being very useful for your end semester examinations. Thank you and happy learning.